just to give you a bit of background, so I did work for a manufacturer for 10 years. One of the main roles there was to lead some of the European-funded research and development projects into design for manufacture and assembly, but how you can design whole buildings and systems and cities using those kind of approaches. So for me, digital manufacturing is more about processes that you can use in construction and other industries, not just about the products themselves. So I now work for PCSG. So PCSG, some of you may be aware of Mark Bew, who's my boss. So he chaired the BIM Level 2 task group and chaired the Digital Built Britain. So I just want to start with a couple of reasons why we need to change as an industry. We've had lots of arguments for change already today, but just to give you some of the headline figures. So purely looking at residential, to start with, globally, over the next 10 to 12 years, the urban population alone is expected to grow by 2.5 billion. And that's the equivalent of 1,900 plus buildings per day, each housing 100 people. One of the reasons I show that slide is not just to put a size on the task ahead, but we can use digital technologies to improve the design and speed of construction projects and so on. But we also need to think of the practicalities of delivering those buildings and systems as well as all the other supporting infrastructure, schools, roads, hospitals, and so on. Another challenge is the performance of buildings in use. So Innovate UK did some analysis a few years ago across a number of different sectors, and on average, I think this was for housing in particular, homes were emitting 3.8 times the carbon that they were designed for a number of reasons, partly because of the design software that was used and the assumptions used within those softwares, but also the design assumptions through architects and so on, but also then going on to the quality of construction. So basically, to summarize those kind of head-level tasks, we need to significantly change the way we're delivering buildings and infrastructure. So better performing, quicker, using less resource, safer, and so on. So in terms of digital technologies, I won't go through all of those now, but there are loads and loads of digital technologies you've probably heard about recently. So summarized into digital technologies for improving design, creating digital twins that we were talking about before, storing, sharing information, and accessibility of that information. All very useful technologies for construction. But what we really need to do is look at how we can pull all those together. So you use the technologies where they most add value. And you do that by making sure you're very clear on what the benefits of different technologies are and how they can work together. So when we talk about, in terms of construction, digital twins, so a virtual mock-up of a building or a piece of infrastructure, the best example I can come up with as to what a digital twin was, I was at a conference a couple of weeks ago, a cross-industry conference. And I don't know if you've heard of Babylon Health. They do an app on smartphones where you can speak to a GP through your smartphone. They're developing a system that they call a digital twin, which is a human body that starts to, once the GP is asking you questions on your health as you go through an appointment, they can see the virtual twin of your body, not the shapes and size and everything, but to understand what conditions you've had in the past, what conditions you're likely to have in the future. For me, a digital twin is exactly the same for construction. So it's not just about the delivery of a project, delivery of a construction asset, it's about the full life cycle of that asset. How can it be managed effectively in the future at the same time? So to do that, we need to start to look at some of the language we've heard before as well, some of the initiatives we've heard of before today. So Industry 4.0, so integration of supply chains. That's integration from product supplier, material procurement, all the way through to asset management and so on. But also in vertical integration, as I call it, the other way, which is integration of different departments within a manufacturer's business. So linking finance, production, and so on. We also need to link that to the design and use of the assets themselves. So when you talk about circular economy, Martin mentioned, For me, that's also about the design of buildings and systems as well. So how do you optimize the use of buildings? So if we're designing buildings now that are going to be used for 80, 100 years, obviously the requirements of those buildings are going to change significantly over that time period. So how do we design in the flexibility to reconfigure or replace those buildings as they go along? And finally, intelligent built assets. How do we make sure we use the Internet of Things to understand the real performance of buildings and systems? This is a really boring bit, so I'll skip through this really quickly. In terms of structuring product data, so how as a manufacturer do you benefit and how do you start to share the information in your products and systems? For me, the priority absolutely is always to start by structuring your own data internally. By that, I mean starting to understand the common properties that you need to describe your products and systems, whether using the top couple of sections there, it's an essential requirement through standards, or whether it's to do with how you can operate your business more effectively, share information internally. And then towards the bottom, how do you, when you go into a specific sector or specific client, make sure that you're using consistent terms and systems that they can use internally. So using some examples, some international manufacturers that we work with have used this very simple kind of structure here and reduced by about 30% the number of properties, data properties that they need to manage across their businesses. So even just in terms of the amount of data storage and so on, it's quite a significant saving. When we go on to new forms of construction, new ways of working, this came out on Monday. Some of you may have seen it. A call for evidence to look at new ways of constructing, so design for manufacture and assembly, or DFMA as it's called. And a platform approach, which is how you can start to standardize systems and spaces and so on to use across a number of different sectors. For me, the priority here, or the main issue here, is we need to look at, first of all, systemizing the whole supply chain, systemizing the design and delivery of assets, before we necessarily jump in and say off-site manufacturing is the solution to every use case, because it isn't. If we start to digitalize the supply chain and understand where the real value of new approaches to construction are, new approaches to integration are, then we're going to have a much greater chance of success. When we talk about the supply chain itself, one of the issues here is to understand there's a huge amount of information lost at the moment from the point of manufacture, or when a product or system leaves the factory gate, as it were, to when that product or system is installed on site. One of the things that we're looking at, we're working on a project, just about to start on a project with Innovate UK, and with the CPA and others, to look at how we can start to make sure, using these digitally connected supply chains, that information is retained all the way through the process. I'll explain why in the next couple of slides. But one of the things we do is we look at every single process, from the delivery of a product all the way through to its installation, as a combination of those 5 different aspects there, the rings. So what the product is that starts at the beginning of a process. So for example, if I use the example of a brick, laying a brick as a really simple product. So the product starting the process may be a brick, and the process itself may be installing that brick as part of a wall. So what skills do you require to do that specific task? So when we've been talking about competencies earlier, one of the things we need to be clear on is, what are we saying we need a competency for? What's the specific task? So, as Steve said before, I'm an architect by profession, but I certainly wouldn't let myself loose on designing a new school or anything like that, because it's been a long time since I've done it. But I certainly still have some of the capabilities required to be an architect. So what we need to do is make sure we have the skills to do a specific task or specific process. The other thing there is the tools. What tools do we need? And that tool can be something as simple as a screw driver. It could be a wagon to transport, distribute, and so on. And then also, what extra resources do we need? And by resources, that includes energy, includes time as well. How long does it take to carry out these different processes? Then using another example of this, if you look at the standards world, there's an ISO standard on how you start to assess the performance of a building or a system, and how you can start to make sure that everything you're designing, creating, delivering is objective based. So again, you need to be really clear on what it is that you're requiring in the first place to get a good response, a performance response. And again, this is for me talking about design for manufacture and assembly again, because I think that's a fantastic, I certainly think it's a move in the right direction significantly, but we also need to make sure that it meets those overall objectives in the first place. From a manufacturer's perspective, we also need to look at the benefits of doing things slightly differently. So how do we develop our businesses, whether it's by the creation of new products or whether it's adding additional services to those products, whether again it's new ways of invoicing, new ways of delivery, or whether it's actually providing full services to our clients on the right-hand side. I won't go through this in detail, but this is from the report we did with the CPA a couple of years ago now on starting to look at a more integrated supply chain. So basically on the left-hand side in the dark blue you have manufacturing. And by manufacturing here again we mean fully integrated vertically and horizontally, as I was talking about before. So a smart manufacturing process. The design aspects there then of a typical construction project use those configuration rules. So basically the data, structures and requirements that I was talking about very early on. In terms of flexibility, so the customization, you can get through that. If you systemize at the right level, you still get the same kind of flexibility in terms of building, design, performance, and so on. It shouldn't restrict the end output. And then assembly, as we've described it there, so using digital technologies as well as assembly methods, off-site manufacturing assembly, to deliver those intelligent assets. But really importantly here, the dotted lines there are giving feedback back to the manufacturing process, back to the designers and the supply chain, to help make sure that any innovation, any benefits gained can be fed back into the next projects. And then another key aspect for me here, the circular economy aspects, which I'll come on to explain a bit. The other important thing here is to realize the use of digital technologies in construction or the built environment aren't just about the delivery of new projects and assets. It's also about the management and operation of existing buildings. So these figures here come from the Office of National Statistics and the English Housing Survey. So if you look at the green ball on the left-hand side there, this is for London only. Every few years there's an English Housing Survey, some of you may have heard of, where a sample number of houses across the country are assessed in terms of their performance, in terms of energy, performance certificates, and they're also assessed in terms of health and safety. So how do they rate on the housing, health and safety scoring system? Just in London alone, if buildings that were not performing to that baseline standard were upgraded to meet that standard, so we're not talking about current building regulations for energy performance and so on, we're just making sure they're at a safe level, then that would cost around £1.35 billion to rectify that housing stock. If you then look at the energy savings as a result of that over an 80-year life cycle of a building, we're talking about £41 billion in savings. And then if we look at the savings to the NHS, which is where these figures come from, for the first year of treatment from a condition that's directly related to living conditions, so whether it's trips and falls or whether it's through damp or cold, then again we're talking about £260 billion in savings. So we're already starting to work with a number of different local authorities and new cities using this kind of logic, evidence-based approach to saying this is where we can potentially look at across industry again, where the benefits of using digital technologies are, and start to understand where we should be spending the money. So I'm not saying we should go out tomorrow and spend £1.35 billion in rectifying the London housing stock, but if we were to, you'd see those kind of savings. So the project I just mentioned that we're just about to start, just to explain the logic behind that quickly. If we start with a traditional model to delivery on the right-hand side, owner-operator decides they need a new house, a new floor, extension, whatever. And on the left-hand side, you have lots and lots of product manufacturers. You obviously have design teams in there, but I'm talking about the physical delivery here. The lozenges you see in there are any step, any product or process from the manufacturer all the way through to installation and operation in that building. So just to give you an example, because I used to work for a steel manufacturer, steel columns as they come off a production line then need to be cut to length, taken to a fabricator, cut to length again for a specific project, drilled, finished and so on, before they're then taken to site and connected up. So there's a lot of different processes in there. When we're talking about digital information, this is where a lot of the information is currently lost, from the manufacturer all the way through those processes to installation. So where information becomes crucial, how do we make sure that that information is retained? So we've heard before the term golden thread. This is one of the ways of beginning to address that. So as with these traditional processes, that information is lost as you go through the process. You still have in the blue area there, main contractors, subcontractors and so on who integrate products and systems, of course. You do. One way of looking at off-site is you sometimes get off-site main contractors that go towards the manufacturing aspect and integrate. And you also get manufacturers that go the other way. So manufacturers that produce the raw materials and products and systems and then head towards into construction. But you still always get those interfaces that need to be managed on site. So what we're looking at now is what we call a digitally connected supply chain. So how do you use digital technologies to integrate that whole process? So one of the things we're doing over the next year is to develop those processes. We've already done it in one sector, but how do we deliver those processes to make it easier for that data to be shared all the way through the process? And also incentivize everyone in that supply chain to do it. So when we've been talking about change before, how do you get people to change? You need to understand the drivers of each of those players within that supply chain. When this has been done in other industries, the key driver has been cost savings. In some industries, in other industries, it's quality. So if you're looking at healthcare, for example, the priority is quality as opposed to cost. But you can play with those different mixes of cost and quality in terms of priorities by having that connected supply chain. The other benefit here is, again, in terms of circular economy, so reusing products and systems, whether it's within your own estate or whether it's re-entering them into the supply chain, you can start to understand the skills required, the cost required to reuse and reposition those products and systems, but also the target cost of doing it. The other reason for, in terms of a digital twin, this is one example of a digital twin. So when it comes to manufacturers and digitizing their information, structuring their product information, you can use it for things like this. So this is in a very dangerous environment. But what we did here, we used just simple gaming technology with structured data to make it so anyone that was going to be maintaining these this plant room didn't have to go on site beforehand and risk themselves. They could just sit in an office environment, look at that model, understand exactly what they needed to do, get all the product information, system information from that model in a safe environment. We're also using digital technologies, again, based on manufacturers' product data, to understand the benefits of viability of whole developments or housing estates. And in doing that, we've demonstrated on a number of projects, you can take the time to assess the viability of a project from about 6 weeks down to 10 minutes. And it's all based on pulling together data from different sources, government sources, house prices, land prices, and so on, and then combining that with manufacturers and systems data. So we're already starting to work with, again, local authorities to understand how you could do that across city development. That's it for me.